Hello students of Biology 209. This project was done by Rebecca and Kevin, and today we will be presenting the topic of the cultivation of seaweed.
We probably have all heard of nori, and most likely have eaten it as well, either in the form of sushi or roasted seaweed.
But how is it made? Today we'll be looking at the cultivation and process of producing seaweed in Japan.
But first, let's look at some background information of seaweed itself. The dried seaweed that we all eat and love comes from the organism Porphyra yezoensis, which is a red alga.
This is what the red alga looks like. It consists of a holdfast, which roots the seaweed down to the ocean floor, the stipe, which connects the roots and the blades together, and to note that it is long so that sunlight can reach the blades for photosynthesis. And finally, the leaf-like structure is the blade, where photosynthesis takes place.
Actually, there is one more thing that takes place on the blade as well: sexual reproduction. So let's take a look at the life history of seaweed.
Porphyra has a sporic triphase life history, where it is also heteromorphic. So what does this mean?
In sexual reproduction, the carpogonia is fertilized with the spermatangia, which gives rise to carpogonia, which divides to form packets of spores called carpospores. These carpospores germinate and produce the filamentous conchocelous phase, which eventually leads to conchospores. Through the conchospores, young thalli are produced.
And in asexual reproduction, vegetative cells directly forms archaeospores, which germinate to form the thallus. However, for the cultivation of seaweed, we will only look at sexual reproduction.
So why is this important? This information was a turning point in Japanese aquaculture, and it's all due to Kathleen Mary Drew Baker, who is regarded in Japan as Mother of the Sea. So what did she do to earn this title?
Some background knowledge of Japan is that the art of cultivating seaweed has been practiced for centuries. However, because of World War II, natural disasters such as typhoons, pollution, and fertilizer runoff nearly caused nori industries to collapse at that time.
Kathleen Baker was one of the first two women to graduate with first-class honors and was awarded the DSc in 1939. So what did she find that changed Japanese aquaculture?
Drew Baker was studying conchocelus that looked like pink sludge and grew on the inside of abandoned shells, which is especially common during the summer months while seaweed appeared in the winter months. Drew Baker discovered that this pink sludge and seaweed were of the same alga.
Seaweed in the winter would send out spores that, in the summer, grew as pink sludge in shells. And come winter again, this pink sludge would send out more spores to build up more seaweed for the next summer.
But most importantly, Baker discovered that bivalves and their shells were a crucial host environment for development. Drew Baker published this paper in 1949.
Around the same time, Segawa Sokichi, a Japanese phycologist, read Drew Baker's paper and repeated the experiment using Japanese seaweed and found similar results.
This was passed to Fusao Ota, who then developed a method of artificial seeding, which greatly increased the stability and productivity of algae farming.
So what does cultivating seaweed look like today?
In the early germination process, oyster and clam shells connected to a fishing line are attached to nori seedlings. This is to control the growth length of seaweed.
When harvesting seaweed, it must be dried above sea level during low tide in order to prevent algae from growing on top of it, but also to ensure that the seaweed buds themselves keep growing for about a month.
The next step is production, where the seaweed is taken to a facility to be cleaned, minced, and blended into a mixture. This mixture is poured into molds where it can be fan-dried and pressed with a sponge to absorb all the moisture so that it can be roasted.